Good morning, our students, and welcome to today's discussion. Today, we'll be looking at the topic sampling distribution. But before we can comprehensively understand the concept of sampling distribution, we want to look at two major terms. And these two major terms are population and sample. So we look at population, and then we look at sample. What is population and what is sample? When you talk about population, you are talking about the totality of items or units that are under consideration either in a research or in a survey. For instance, when you talk about the total number of students in a particular university, you are talking about the population of students in that particular university. So anytime you are concerned with the generality of persons, items, or objects, either in a research or in a survey, you are making reference to population. However, when you talk about what sample, you are talking about a fraction of this population or a subset of this population. For instance, coming to that particular university and taking some fractions of students from that university. You no longer address that fraction of students as the population of that student. Instead, you are addressing it as the sample from that particular population. And then when measurements are taken from this population, we refer to these measurements as parameters. However, when measurements are taken from sample, we do not refer these measurements as being parameters. Instead, we refer to them as being statistics. What do we mean by that? When you come to this population and you calculate the mean of this population, which in this context might be the mean height of the population of the student in that particular university. You are referring to this mean as the parameter of this population. When you calculate the variance of this population, which in this context might be the variance of the mean height of the students in that particular university, you are referring to that variance as a parameter. The same thing applies when you are talking about what the proportion in this population, which could be the proportion of the students in that particular university that has deformity, either in terms of blindness or in terms of maybe being lame. So that is what we refer to as parameters. And what we now mean is this. When you talk about the following measurement, this measurement, I talk about what number one, and that number one, I am talking about what the mean. Talking about the mean. And of course, you know that this mean is represented with what? X bar. And of course, the formula to calculate the mean of this population is summation that I is running from 1 to capital N of what? X what I all over what? Capital what N. Where capital N here stands for the population size. It stands for the population what size. And then when we talk about what the variance, talk about the variance, then this variance is sigma squared, we close it. So this is given as sum that I is running from 1 to capital N, open a bracket, xi minus x what bar all raised to power 2 all over capital what N minus 1. Then when we talk about the population proportion, talking about the population proportion, of course, which we represent with pi, this will be given as what? As x all over capital what N. where X is the number of students in that particular university that has the deformity of a consideration, the deformity of consideration, which could be blindness, which could be that the person is what is lame, that it is not, the person is not walking. And then this N still stands for the population what size. So what we have here is population mean X bar is given as this, population variance sigma squared is given as this, population proportion pi is given as this. This population mean, population variance, population what proportion, they are referred to as parameters. They are referred to as what? Parameters. Parameters. So when we talk about parameters, we are talking about measurements that are computed from the what? From the population. And these parameters could be any of the following and even more, as long as that particular thing or measure is computed from the population. It is referred to as parameter. However, when we come forward for sample and then we talk about the mean, which we still represent with X bar, the formula is going to be sum I is running from 1 to small letter n of xi all over what? N. Where this my small n now is talking about the sample size, the size of the entity that are collected from the what? From the population. So if you talk about the variance, the variance, we are talking about what? S what squared. This will be given as what? Summation that I is running from 1 to n, small letter n, of xi minus x bar all raised to power 2 all over what? N minus 1. And then when we talk about proportion, here, proportion, which we are now going to represent with a letter what? P, is now going to be given a what? X all over what? N, where our N still remains as our sample what? Size. So when we talk about the sample mean, look at the formula here. It is a little bit different from here in terms of what? Of the size of either the population or the sample. Here, capital N is talking about population of size, population size, and small letter n here is talking about the sample what? Size. So when we talk about what? The sample variance, look at it here. Here is small letter n, but here is capital N. All over capital N minus 1, but here all over small n minus 1. But when we talk about the sample what? Proportion, we represent it with a letter what? P, talking about what? X over n, where this x is the sample size. And in this context, your interest is that you have collected a sample from the population, and from that sample you have collected, you are now concerned with the number of people in that sample that is living with a particular deformity, which could be blindness or which could be what? Being lame. Okay? So one thing of interest here is that in sampling distribution, or majorly in statistics, most of the time interest is to study the behaviors of what? Of the population, either in terms of what? Of the mean height, or in terms of the variance, or in terms of what? Of the proportion. But bearing in mind the two major setbacks of a population, one of which is that it is practically difficult for us now to get all the units in the population that we will be using in our studies or in our researches. We cannot easily go and make use of what? Of population, bearing in mind that we may not be able to get all the units needed for that particular what? Research in that population. Number two, even if we are going to succeed in getting all the units that are in the population to enable us continue our research, the cost implication of getting all the units in the population might be very, very high. And this could be an impediment, or it could be a setback to progressing in our research. What are we going to do? what we are going to do is to resort to taking sample. We take a smaller size or portion of the population and go ahead to carrying our research. And whatever findings we are going to get from our sample, we go ahead to generalizing to that particular population. For instance, if somebody is trying to study the population mean, where this mean could be the mean height of students in that particular university, knowing fully well that it's going to be difficult to be able to get all the students in that particular university, get all the measurement of their height now and be able to compute the average of that height. You go ahead to taking sample either from faculties or just to come inside that university and then randomly select some number of what of the students now, measure their height now, and then get their average. That average which you are getting from that sample now, you are going to use it now to generalize that the mean height of the population of the student in that particular university is whatever value you have got from this sample. And in this context, we are saying that this sample mean given by this formula now is an unbiased estimator of this population mean X bar here. The same thing applies that when you want to look at now the variance of the mean height of students, for instance, if your interest is on the mean height, it could be in another thing, it could be on the weight, it could be on anything you can think about. If you are talking about now the variance of the mean height of the student in that particular university, then you are now going to use this formula now to compute the variance of the population, the mean height of the population of the student in that particular university. However, knowing fully well that you may not be able to get all the units in this population, you resort to taking sample. And from this sample you have taken, you are going to compute what we call the sample variance written as what? As S squared. Then whatever value you are going to get from this sample variance now, you are now going to use it to generalize over this population, saying that the variance of the height of the students in that particular university is given as whatever value you have gotten from this sample. And in that case, what we are trying to say here is that this sample variance, of course, is an unbiased estimator of this population variance, sigma squared here. The same thing applies with what we did proportion. Okay? Now, there is also an important thing which we ought to learn from this. In this case, what is actually the benefit or what we call the advantage of a sampling distribution? But before we go ahead to talking about the advantages of a sampling distribution, we first of all want to paint a clearer image of what is meant by sampling distribution. Because the emphasis we have given thus far is trying to make you understand the population and trying to make you understand the sample and trying to make you understand the essence of taking sample in the first place. But then when we take a sample, one thing can be understood from it. Assuming that we have the sample size n, and this sample size n, for instance, might be something like, let me say, it might be something like what, 20. It cannot necessarily be 20, I am just giving illustration. If you come to a population and you take a sample size of 20, and from this 20 now, you compute the mean height of the student in that particular sample, and you drop the value. You equally return back, and then you take a sample size of say n equals to what? 20 from that population. You compute what? The mean height of the student and you drop it. And you continue to take samples of fixed size 20 from that population and you continue to calculate the mean height of the student in that sample. You notice something. The value you are going to get from the first one might differ from the second one, it might differ from the third one, it might differ from the fourth one down the line. It is always not the same value that you will be getting when you take a fixed sample from a particular population and you repeat it over and again, computing a particular sample statistics, be it mean, be it variance, or be it proportion. The values keep to differ. And because the values have kept to differ, they are no longer constant. It is not constant. They continue to change value, and because they change the value now, they form what is called distribution. And the distribution that describes how these sample statistics, be it what the mean, be it the what the variance, and be it the proportion, changes from one sample to another is what we refer to as sampling distribution. We refer to as what? Sampling distribution. Do recall that we said that this population mean this population variance this population proportion this, they are referred to as parameter. Equally remember that this sample mean this sample variance this sample proportion this are referred to as statistics. They are referred to as what? Statistics. So when you talk about statistics, you are talking about measures that are computed from what? From sample. These measures could be mean, it could be variance, it could be proportion, it could be any other thing as long as it is computed from what? From the sample. But we are trying to say that if you decide to consider a fixed sample size, say n equals to 20, and you come to a population, get a sample of what? Of 20. From that sample of 20, compute the mean, compute the variance, and compute the proportion. Keep their values. Return back to that same population, take a sample again of n equals to what? 20. Compute your mean, compute your variance, and compute your proportion. As you continue to return back repeatedly to take sample of size 20 from the population, computing these statistics and dropping their values. After some time you look at the values, you are going to find out that these values are changing. They are not constant. And because they are changing, they form a distribution. And a distribution that describes these changes in these sample statistics, be it what mean, variance, or proportion, or any other thing, is what we refer to as sampling distribution. So in this sampling distribution, we have types of sampling distribution. And when we talk about types of sampling distribution, we are talking about sampling distribution of mean, sampling distribution of variance, sampling distribution of proportion, and any other thing that you might be considering. But these are the three popular types of a sampling distribution. So that is what is meant by sampling distribution. And somebody might be interested to know what are the importance or the relevance of sampling distribution. We are going to itemize the importance or relevance of sampling distribution. Number one importance of sampling distribution is that it will help us now to study the population parameters or to study the behavior of the population in terms of the parameters of that population making use of what? Of a sample statistics. Because like we had said earlier, we are now trying to understand the nature of the mean of the population using the sample mean. Understanding the variance of the population using the sample variance, and understanding the population proportion using the sample proportion. So number one relevance of sampling distribution makes us now to understand or to study the population parameters now making use of the sample statistics. Number two, of course, that it helps us is that it equally helps us now to estimate the population what parameters. It helps us to estimate the population what parameters. It does that. And number three, it forms the basis of statistical inference. And when we talk about the basis of statistical inference now, we are making reference to what we call the test of hypothesis and then the estimation of the confidence interval, or what we call interval estimation. So these are what we call the importance of a sampling distribution. Now, there are parameters that affect this sampling distribution, and these parameters are three in number. Number one parameter that affects it is what we call the sample size. What we call the what? The sample size. If the sample size is what is small, there is every tendency that you are going to express larger variations in these values of a sample statistics which you are calculating and keeping. But when the sample size now becomes very, very what? Large, tending to the size of what? Of the population now, you find out that this variability now will now be what? Be narrowing down. So number one is that the sample size n affects the sampling distribution. Number two is what we call the population what? Variance. The population variance, sigma square. The larger the population variance, of course, the more one expects variations equally in the sampling what? Distribution. Okay? But the smaller it is, of course, the smaller that one expects it equally. And then the last one is what we call the kind of sampling distribution, or what we call the kind of what? Of a sampling that we are going to adopt. Whether the sampling is going to be with replacement or whether it is going to be for without a replacement. So these are the three major things that affect the sampling distribution: the sample size, the population variance, and then the nature of the sampling adopted in terms of whether sampling with replacement or sampling without a replacement. This is just to give what we call the background or the premises of a sampling distribution. In our next class, we begin to take them unit by unit or one by one. We begin to look at the sampling distribution of what mean. And under the sampling distribution of mean, we are going to look at it now under two categories: when the sampling is with replacement and when the sampling is for without a replacement. And we continue in that order till we exhaust all what we have listed here, the variance, the proportion down the line. As a quick recap, talk about sampling distribution. Reference is always made to population and sample. Population, total entity, persons under consideration in a research, in a survey. Calculate any measure from the population, be it population mean, population variance, population proportion. They are called parameters. Take a sample from this population with the interest to study this population in terms of the mean, in terms of the variance, in terms of the proportion. From the sample taken, obtain the mean, and then use this mean to generalize on the mean of what? Of the population. Regarding this mean as an unbiased estimator of the population mean. The same applies to variance, the same applies to what? To proportion. Trying to categorically understand what is meant by sampling distribution. And of course, this sample mean, sample variance, sample proportion, they are regarded to statistics. So any day you hear about statistics, take your mind to what? To sample. Any day you hear parameters, take your mind to what? To population. Trying to understand what brought about sampling distribution, we say that if you consider a fixed size, sample size, be it n equals to 20, you come to the population of students, collect 20 persons, measure their heights, obtain their mean. From that mean, obtain the variance of what? Of their height, obtain the proportion of what? Obtain the variance of what? Of their height. Keep the values here, return back here, take a sample of what? Of 20 as well. From that sample of 20, still get the mean, get the variance. Repeat it over and again, drop their values and compare. The values will not be constant, they will be changing. And because they are changing, they will form a distribution. And the distribution that describes the changes in these sample statistics is what we refer to as sampling distribution. Okay? Now, when you talk about a proportion, your interest could be on the number of students that are blind in that particular sample or in that particular university. So you come here, you take a sample of size 20. From that sample of size 20, you look for numbers, or let me say that your interest could be number of students who scored maybe less than what 40 in a general subject or general studies. So you now take a sample of what 20, and from that sample of 20, you now talk about the number of students who scored less than what 40 or 45. Then you get the proportion you keep. You equally return back to the population, take a sample of 20, get the proportion. The values will as well keep to what to change, and they will form a distribution. And then this distribution that describes these changes is what we call sampling distribution. For that note, we have what we call sampling distribution of the mean. It describes the changes that occur in the mean when we repeatedly take a fixed sample from what? From the population, and obtain the what? The mean. So we talk about the sampling distribution of variance. It describes the changes what in the variance when we take a fixed sample size repeatedly from what? From the population. The same thing applies from what? From the variance. Thanks for your audience for today, and stay tuned as we continue from now to unveil all about sampling distribution. Thank you, and then remain blessed.